Let's recap a couple things. First thing we did today was we solved only trigonometric problems that had a right triangle. The fortunate thing about what we're doing is the law of sines also applies for right triangles. I don't typically use the law of sines with right triangles, but you could if you wanted. All right, so what we did, whenever we had a right triangle, we used trigonometric ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Then what we did was we moved to a problem that had no right triangles. When you have no right triangles, you cannot use the trig ratios we discussed earlier. You must use some of the new ideas that we're going to talk about for the remainder of the show. And if it was unclear what we talked about, you call 312-738-1060. Let's look at another problem. All right. So let's try to create another problem. I tried to create a problem in my head, and I made them. I created a bad problem. That's why I had to erase. What we did earlier. Oh wow, man! I just remembered something. We got so much to talk about today. I brought in some ACT problems. Aren't you excited? I brought in some ACT problems. Let's take a look at that. You're not calling in. I just got so much to do. You're not calling in. Let's take a look at an ACT problem. All right, let's take a look at this problem right here. All right, you can't read it, but I'll read it for you. It says, estimate the height or the altitude above the ground of balloonist radios to an observer on the ground that he is directly over a barn. So this is a barn, this is the observer. All right, this says that the observer is 800 feet from the barn. They labeled everything for you. It says the observer's angle of elevation is 35 degrees. By the way, an angle of elevation is just an angle measured up from the ground. This is the ground. The angle of elevation is measured up from the ground, 35 degrees. It says, which of the following best estimates the balloonist's altitude above the ground? All right, so what's this altitude? What's that height there? And then they give you a bunch of answers. They give you the answers here, and it's your job to be able to determine which of these represents the answer here. So let's use the techniques that we talked about previously. All right, so using the angle as a reference, using the angle at this 35, each of these angles have 30. Oh, you can't read it, but each of these answers have 35 in it. So this is the angle in question. This is the opposite of this angle. This is the adjacent of this angle. This is the adjacent of this angle. This is the opposite of this angle. All right, so that tells you right away when you have an opposite and adjacent, now you won't have this sheet in the test. On the ACT test, you won't have this sheet, but what you have to do is you got to practice, you got to study so that these ratios are in your head and in your heart. These ratios in your head and in your heart, so you can recall those at a moment's notice. So opposite, adjacent, you immediately think tangent. All right, so we have the tangent of the 35 is equal to the opposite, which is unknown, over the adjacent, which is 800. You want to solve for the x, so you cross multiply. That's over 1. You get x is equal to 800 times the tangent of 35. 800 times the tangent of 35, and that you might not be able to read it, but that's that problem right there. That's the answer right there. So the correct answer would have been E. The correct answer to that would have been E. All right, so let's go mastery level. Let's say this was not offered. Another possible answer on the ACT. This is a college prep test. All right, so another answer could have been, they could have provided an answer that had this angle right here. All right, so if this angle right here, this is 55. All right, so that's 55 because the sum of the interior angles on a triangle have to add up to 180 degrees. So if that's 55, another answer they could have offered, all right, so if given this angle, if that's the opposite, This 800 is opposite of the 55. This unknown is adjacent to the 55. They could have offered, when you have the opposite and adjacent, that's the tangent trig function. So you have the tangent of 55 is equal to the opposite. Opposite of this angle is 800. Opposite of that is 800 over the unknown adjacent. Let's call that x again. You cross multiply. You get x times the tangent of 55 is equal to 800. If you're solving for this x, you divide by the tangent of 55 on both sides. You divide by the tangent of 55 on both sides, and your final answer would end up being 800 divided by tangent 55. If they would not have offered E as an answer, they would have had to have offered that. All right, so that's a mouthful again. If you have questions on anything we're talking about, that's the ACT test. And there are a lot of subjects on the ACT, but trigonometry is definitely one of them. Let's move on. We have so much to discuss with you. So much to discuss. Let's look at another problem. All right, so let's look at another problem where we do not have a 90-degree angle. All right, let's put together a diagram. Let's put together another diagram like so. Hopefully I come up with a good problem this time. Hopefully I don't come up with a problem that cannot be solved. All right, so let's say that this is 100 degrees. Let's say that's 100 degrees. Let's say that's a 100-degree angle. And let's say this is 9, and let's say this is 6. Let's say I can make a better diagram where you can see it. All right, let's say that. All right, let's try to make a triangle where you can see the sides and the angles a little bit better. All right. So today, what I'm doing is I'm focusing on triangles now that do not have a 90-degree angle. All right. So let's take a look at this triangle here. There is no 90-degree angle. This is a 100-degree angle. That's a 100-degree angle. All right, that's a 100-degree angle. And let's say this side is 6, and let's say this side is 9. There is no 90-degree angle. So none of these ratios apply. Sine, cosine, tangent. None of those trigonometric ratios apply. And by the way, I told you that you're going to use the law of sines when you have an angle and the side opposite. I want you to be able to see here, you don't have an angle and the side opposite. You have an angle, but you don't have the side opposite. All right, so you got to have yet another technique, which is called, this technique that you're going to need to know now is called the law of cosine. All right, so you're going to use a law of cosine when you have 3 sides or when you have an angle side, a consecutive angle side angle. All right, so you're going to have to use a law of cosines when you experience these types of problems, and that's the case here. You have an angle, I meant to say side, angle, side here. Forgive me. If you have side, we're going to use the law of cosines if we have a side and angle, forgive me, side, angle, side. All right. If you have 3 consecutive sides or if you have side, angle, side. That's what we have here. Side, consecutive side, angle, side. All right. So let's call this A, B, C. All right. A, B, and C. All right. So let's try to get this. Let's try to get this side right here, side A, lowercase a. All right, and the only way you're going to do it, you can't use the trigonometric ratios because we don't have a 90. And you can't use a law of sines because with the law of sines, I told you, you had to have an angle and the opposite side. We have an angle, but we don't have the side opposite. So now to get this side right here, we're going to use the law of cosines. We're going to use this law of cosines right here. So we have a squared is equal to b squared plus c squared minus 2bc times the cosine of a. Let me write it down right here. So we have a squared is b squared plus c squared. B squared plus c squared minus 2bc cosine 108. All right, so let's substitute into this law of cosines. So we have a squared is equal to b squared is equal to b squared. That's 9 squared plus c squared. That's 6 squared minus 2 times 9 times 6 times the cosine of 100. All right, so we have a squared is equal to 81 plus 36 minus 18 times 6, 18 times 6, and we have 108 times the cosine of 100. Don't forget, we got to be in the degree mode here. Times the cosine of 100. So that's times a negative 0.1736. All right, so we end up with a squared. A squared is equal to 81 plus 36. We end up with 117. And we have a negative times a negative. A negative times a negative. That's a positive. All right, so now we have 108 times 0.1736. All right, so you end up with plus 18.75. 18.75. All right, okay, so that's a negative times a negative. That's a common mistake that a lot of students make. That's a negative, and this is a negative. So a negative times a negative ends up being a positive. So you add that to 117, and you end up with a squared is equal to 135.75. And now you're just going to take the square root. Take the square root, and you end up with a is equal to 11.65. Final answer.